Welcome to The Explainer. Today, we're venturing right behind the drywall to demystify the critical structural bones of your home. If you've ever walked across a surprisingly bouncy floor or spotted a strange dip in your ceiling, well, you are absolutely in the right place. Let's get right into it. So, let's kick things off with a pretty fundamental question. What exactly stands between your heavy living room furniture and a catastrophic collapse right down into the basement? It's honestly something we take totally for granted, right? We walk on our floors every single day, we load them up with massive couches and heavy appliances, but we rarely stop to think about the hidden framework holding the whole shebang up. Looking at this foundational map for today's health check, you'll notice it's basically a hierarchy of heavy lifting. It's like a giant puzzle. The floor joists are those tightly spaced boards right under your feet. They're the front line. They carry the immediate weight of the room and transfer it down to the much larger beams. Then, those beams shoulder that massive combined load and carry it all the way outward to the vertical columns or directly to the foundation walls. Section 1. Invisible Forces and Loads. Let's talk about the actual physics at play in your home. Gravity literally never takes a day off, and neither does your home's framing. Beams carry massive vertical loads, and when they fail, they typically fail through bending. This is basically a constant, intense tug-of-war between compression crushing the top half and tension pulling apart the bottom half. Just imagine holding a thick piece of foam and bending it downwards right in the middle. The top surface squishes together. That's your compression. The bottom surface stretches out. That's the tension. Wood is actually fairly good at handling both of these forces, but it's slightly better at handling the compression side of things. Now, visualizing these invisible stresses is absolutely crucial. Notice how maximum shear happens at the extreme ends near the columns, while maximum bending stress threatens the very middle. Just look at the directional forces there. The downward force of the joists in the center is constantly fighting the upward supporting force of the columns on the ends. What this means in practice is that the very center of the beam is working the hardest to keep from snapping in half, while the ends are working overtime just to keep from shearing or, splitting apart along the grain. Moving on to Section 2, diagnosing beam conditions and spotting those critical structural warning signs. When you're inspecting, you need to look out for major, obvious defects like severe splitting due to shear failure. But you also have to watch for insidious, sneaky issues like a beam rusting on totally inadequate concrete shims. Think about it. A severe split at the end isn't just a natural drying crack. It starts right at the edge and severely weakens the beam's ability to actually hold the load. On the flip side, you might have a beam that isn't splitting at all, but the shim, the little spacer material placed between the beam and the foundation block, is completely insufficient. Steel beams absolutely need welded steel shims, and wood beams require dense, mechanically fastened wood shims, no exceptions. Proper load transfer is just a game changer here. Without the right bearing width on solid masonry or that vital half-inch airspace in foundation pockets, the wood will quickly succumb to either crushing or rot. So the golden rule for beam ends? You need 3 inches of solid bearing on masonry, or 1.5 inches on wood or metal surfaces. And if a wood beam is tucked into a concrete foundation pocket, it absolutely must have a 1/2 inch of airspace around the top, the sides, and the end. Without that breathing room, moisture from the concrete transfers straight into the wood, and bam, you get wrong. So this brings us to a universal, unbreakable rule. You absolutely must not notch or drill into beams. Period. This is especially true on the bottom edge, where the wood is already fighting those intense tension forces we just talked about. Remember that tug of war? If you cut a notch into the bottom of a beam, you are literally severing the exact wood fibers that are desperately trying to hold the whole thing together under tension. It is a massive, massive structural compromise. Take a look at a real-world example of a cut beam. The real danger here is a delayed reaction. Everything might seem perfectly fine until, say, a new homeowner brings in a massive, heavy aquarium, causing a sudden and significant deflection. You see this all the time in older homes, right? Someone prioritized running a plumbing pipe over the actual structural integrity of the house. The scary part is that the floor might not cave in the very next day. The subfloor and the surrounding joists might temporarily bridge the gap, but the exact moment you add a new, heavy live load, that compromised beam is going to fail, for sure. Section 3, the role of floor joists. Let's look at the frontline workers of your floor system. For any DIYers out there evaluating their own homes, these rough span limits are incredibly handy. You can actually spot an overspanned joist just by measuring its depth. Assuming a standard 16-inch spacing, a 2x6 really shouldn't span more than about 9 feet without a support beam underneath it. Moving up, a 2x8 spans about 11.5 feet, a 2x10 gets you to 14 feet, and a 2x12 can stretch to roughly 16 feet. If you step into a converted attic or DIY addition and immediately see 2x6 joists spanning 15 feet, well, you instantly know why that floor feels like a literal trampoline. Now, because lumber naturally bends, carpenters have to install joists crown up. Why? So that when the heavy floor weight is finally applied, the wood deflects downward into a nice, flat, straight line. If you look down the edge of any long piece of lumber, it almost always has a slight curve to it. If a builder accidentally installs a joist crown down, they're basically creating a built-in low spot in the floor. And trust me, that dip only gets worse once you start placing heavy furniture on top of it. Section 4. Spotting joist deficiencies. Time to learn how to recognize the structural warning signs. It is absolutely vital to know the difference here. A sagging floor dips right in the middle, which generally means a joist is failing. But a sloping floor, that tilts from one end of the room all the way to the other, indicating a much more serious foundation or column shift. A sag is usually a localized framing issue, maybe an overspan joist or a single damaged piece of wood. But a slope, that tells you the entire support structure at one end of the room is physically sinking into the earth or settling. It's a whole different ballgame. So what if your floor vibrates wildly every time you walk past the china cabinet? Well, you can actually dampen that springiness by tying the joists together with bridging or blocking to share the load. A floor shouldn't act like individual piano keys where one presses down independently. You want the whole floor system to act as a single cohesive unit. Adding cross-bridging or solid wood blocking between the joists forces them to share the weight, which significantly reduces that annoying vibration. It's a remarkably effective fix. Finally, if you're looking around down there, always investigate prior repairs, like a sister joist, to deduce exactly why it was added in the first place, and to ensure the underlying structural movement has actually been stopped. Sistering, which is just bolting or nailing a new piece of lumber directly alongside the old, failing one, is a very common and effective fix. But as an informed observer, you always have to ask yourself, what actually caused the original joist to fail? And was this repair done robustly enough to carry the current load? Armed with this structural diagnostic guide, take a flashlight down to your basement and seriously ask yourself, what secrets are my floorboards hiding? Look for the spans, check closely for those unauthorized notches, and really inspect those bearing points. It's truly fascinating stuff once you actually know what to look for. So, what's holding your house up today? Thanks for joining me on this explainer, and keep learning.